Alright, we'll start with the numericals. This first we'll just go through the formulas that are there in this chapter. So the very important one first, torque is force into perpendicular distance. Right? So if the torque has been given to us of force, so torque is force into perpendicular distance. Right? So if any body, this is formula is for any body that has been pivoted. Okay, so for example, okay, there's a pivoted, there's some force that has been applied. F is the line of action of force. This is the perpendicular distance. This is R, this F in that case. So torque is force into this perpendicular distance. Okay, whatever the force is, so it is 10 Newton into this distance, it's 0.5 meters. So in that case, the torque would be the multiple of both. Alright. Second, the moment of couple, either force into perpendicular distance between the force. So for example, a tap is there. So force required to open a tap. So there would be two forces in opposite direction. So if you are applying a force in this direction, the other force would be in opposite direction, this direction, of equal magnitude. So if this is of 10 Newton, this will be also of 10 Newton. In that case, we can apply this formula where two forces are acting in opposite direction. We can use this moment of couple to find. So in that case, we will use either force. So one force, that is any one 10 Newton you can take, and this total distance. Okay, this will give us the moment of couple. All right. The third one is sum of anti-clockwise moment is equal to sum of clockwise moments. For example, there is a seesaw. Okay. So if there is some weight that has been kept over here, it will generate a anti-clockwise moment. If some kid is sitting over here, in that case it will generate a clockwise moment. Now if it is in equilibrium or if it is balanced, okay, that means the sum of anti-clockwise moment, so whatever the moment that has been generated by this weight and this length, okay, the torque whatever we generated by this weight and this length is equal to the torque that has been generated by this length and this weight. Okay, so it's W1 into L1 is equal to W2 into L2. Okay, alright, so let's start with numerical one. So first we'll note down what has been given to us. Okay, so what has been given to us? Force, okay, 10 Newton. So force is equal to 10 Newton, and so moment of force of 10 Newton about a fixed point O is 5 Newton meter. So we know the unit of torque is Newton meter, so it's 5 Newton meter. This is the torque that has been given to you. Calculate the distance of point O. So what we have to calculate? We have to calculate the distance at point O, that is the pivoted point, and the line of action of force, and where the line of action of force. So as we did in the previous diagram, so suppose this is a body, it has been pivoted over here at point O. If there is a force that has been applied, so this will be line of action of force and this will be the perpendicular distance. So force is given to us as 10 Newton and torque that is generated over here is 5 Newton meter. Okay. So we have to calculate what is the distance. This is R. Okay. So R is how much? We know that torque is force into distance, but we only want distance, so we'll rearrange this equation. We'll send the force on the other side. So torque upon force is equal to distance. This can be simplified or written as distance is equal to torque upon force. Torque is 5 Newton meter, force is 10 Newton. Newton get cancelled. Okay, 5 by 10 is equal to 0.5, remaining is meter, so it will be meter. So distance is how much? 0.5 meter. Alright. Okay, second one. Okay, a nut is opened by a wrench, so there is a wrench or a spanner. Okay, so there is a some kind of a spanner is there. Okay, and there is a nut over here, for example. So this distance is given to us as 10 centimeter. For least force, so the minimum force that is applied, so suppose we are applying a force in this direction. The force is 5 Newton. So what is the torque that has been generated over here on the nut? Okay. So first we'll write down what has been given to us. So for us the distance is given as 10 centimeter. Force is given as 5.0, that is 5 Newton. What we have to find out, torque is how much. Now remember one thing over here, the units, okay, the distance is given in centimeters, so we have to convert it into meter. Now 10 centimeter, you can write it as 10 by 100, that will be 0.1 meter. Okay, now why we divided this by 100, I'll just give you a quick explanation over here. So we know that 1 meter is equal to 100 centimeter. Okay, so 1 meter can be said to be 100 into 1 centimeter, since we want only 1 centimeter over here. So 100 will be sending over here. So 1 upon 100 meter is equal to 1 centimeter. This can be written as, so this can be written as 1 upon 10 to power 2 meter is equal to 1 centimeter, or simply 10 to power minus 2 meter is equal to 1 centimeter. So whenever you are converting anything from centimeter to meter, you multiply it by 10 to power minus 2. So here also we did the same thing. So 10 centimeter, you multiply it by 10 to power minus 2. 10 to power minus 2 is nothing but 10 into 1 upon 100. Okay, so we divide by 100. So whenever you are converting anything from centimeter to meter, you divide it by 100. 0, 0 will get cancelled. 1 upon 10 is 0.1 meter. Alright, so this is 0.1 meter. Now we know torque is force into distance. Force is 5.0 Newton. Okay, so forget about this, you can just consider this as 5 into distance is how much? 0.1 meter. Now when you are multiplying, forget about the decimal, you simply just multiply. 5 ones are 5 Newton meter, then you put a decimal before it. There's one decimal point after this place, because this decimal, it is after decimal, this is 0, so it doesn't make any sense. So it is 5 Newton meter. Okay, 0.5 Newton meter, I'm sorry. Alright, we'll stop over here, we'll continue later.